Okay, this is the model run that came in at 6 a.m. You can see this is what was supposed to be now at 12, but there's no action right now. I'm looking out the window right now and it's clear. I could only see a few floating cumulus clouds, and all the precipitation has already shifted off the coast. Boston is already clearing up, just getting the last bit of rain. All this, there's already lake effect snow here. So we're like getting weather like this now. So we're at hour 12. So, and everything's starting to clear out. So we'll probably get a few flurries from the lake effect, and maybe some from here, from this system coming in here, but I doubt it. But there's going to be a system later this week, I think on Sunday, that could produce some good snow, and Monday, that could produce some good snows for Boston and for New York City. How much? Okay, for New York City, the snow starts at 78 hours out, or 72 or 78, somewhere around there. And it's going to last up to around 96. So this might be a 24-hour snow event for the city. How much snow are we talking about? If the storm is very weak, maybe 1 to 3 inches for New York City. If it's very strong, we might get as much as a foot. But still, the model, lately the GFS has been very unreliable, and it constantly flips and flops. So I'll take you to the European model, which is showing a similar scenario. But the problem is on this college website, weather-related part of the College of DuPage, it only goes 24-hour intervals, and you can see a low forming here. Okay, this is the run out of midnight. The next run will come in at 1.5 hours. Okay, I will go to classic.weatherunderground.com or wunderground.com. Then I'll go to models, model maps, and okay, close this ad. The sponsors. Okay, go to model data, click right here, and then go to European. I'll show you the two different runs. I'll show you wind and knots. I'll zoom in so you can see a little better. You see these reds here represent wind gusts between, let me see, the yellow, so that'll be here, orange, here, wind gusts between 40 and 45 knots. So you can see over the lakes there's winds between 30 and 40 knots, or 40 to 50 miles per hour. So there'll be good lake effect snows here. So the lake effect streamers will come down out of here, and sometimes the lake effect bands might feed into other lake effect bands from other lakes. So you might get a band from Lake Huron coming out here, and it might merge with Lake Ontario, and it might produce like a double band. And sometimes you might get a band coming this way and another band coming this way. It's rare, but sometimes you might get that, because the winds like here coming out of the northwest, here coming out of the southwest, and that sometimes pushes the band towards the south to Syracuse, New York. And one time a lake effect band made it down towards New York City from Lake Ontario. It separated from the lake. It produced like almost 2 feet of snow in Syracuse. But by the time it made it down to New York City, still as a pretty potent squall. We got like a dusting. But let's move on. I will show you 51 hours out, and now 75. High pressure system off the coast. Weak low pressure system here. I'll show you MSL, or mesoscale surface level. And nothing much. Okay, let's go out to 90-something, 84 hours out. Now things are getting interesting. You can see the winds are like all over the place. Winds are out here out of the west, northwest. Here winds are out of the south. Here the winds are all over the place, and that usually tells of something developing. But you can see already there's precipitation down here towards the Carolinas and into Georgia. I'm going to zoom out so you can see more. Okay. And you can see there's almost a trough developing, but not quite. Okay. winds and knots again. Let's go to 90 hours out. But this run is the old run. This is from 12 a.m. This 12 p.m. yesterday. This is the current run now. Okay, let's go to MSL again and show you the difference between this run and last run. Okay, see? Let's go. I'm gonna go up ahead a little bit. Move up a little more. Now you can see moderate precipitation beginning to come into Long Island. The run between here and here, you can see all this moderate precipitation here, but nothing much here. But now all of a sudden it's showing more moderate here. Okay, 108. That shifted off the coast, and now you see this coming in. 126. I'm gonna move 6 hours out. So it looks like New York City might get a little snow from this. Light snow coming into New York City on Friday, on Tuesday, February 5th at 9 a.m. Greenwich Mean Time. And you can see if I'm going to zoom in, okay, I'm going to zoom in right here. You see a low pressure system here. But what's weird is there's almost no wind. Look, purple. Okay, 3 to 6 knots, like 5 to 10 miles an hour. Green, 12 to 15 knots, not even 20 mile an hour winds. That is not right. That's something not correct. If this was an actual low, you have maybe 15, 20 mile an hour winds at least, or maybe like. But look, no precipitation. Low. Where's the precip? Okay, something isn't right. Usually when a model is so far out, it tends to make mistakes, and you can see. The low moving across central Pennsylvania, and you can see, and then a tiny low developing over Long Island. Okay, that's now, and then look, and yet there's barely anything. 144. Okay, now it always stops working when you get to 150 hours out. So I'm gonna go back to weather.cod.edu. Weather. Okay, hold on. The name of the website is www.weather.cod.edu/forecast. So it's a college website. College of DuPage. You're located in DuPage, Illinois. It's just west of Chicago. They have storm chasing classes. I've never been there, but I heard about it. It's a very good school. I still haven't gone to college yet. I'm still, waiting for college. Okay, so for us to get a big snow, this plume of moisture from the Gulf will have to come right into New York City. And this 5400 line will have to stay to the south, because I'll show you temperatures. Because, see, right here, we might be having a rain snow line way to the south, but you see how close the freezing line is to the coast. This is the freezing line right here. So, what might happen in New York City in this scenario? You might be getting wet snow mixing with rain. Yes, but you're thinking, how could that happen? The rain snow line is so far to the south. Yes. So, the models will probably have to work it out, but... So, most likely what will happen is we're going to get like a wet snow. If the low is a little stronger, and this trough is a little more deeper, we might get a pretty potent storm. I did say a few days ago that I believe the storm is going to be a little more potent, yet they were showing almost nothing. That's indeed what happened. How much do I believe New York City is going to get? If this goes further to the east, less. If it goes further to the west, more. This plume of moisture will have to come directly over New York City for us to get a good accumulation. But unfortunately, it seems it might go a little further to the east. And most of the moisture, if we get any, will be on the wraparound. The best chance we have of getting any snowfall, especially high snowfall, is if the storm forms like here and then moves up like this. Then we might get a lot of moisture on the western side. But unfortunately, I don't see that happening just yet. But the way the models have been lately on the positive trend for snow, especially this one, the GFS, I am pretty confident that we might get a good snowfall, especially in Boston and potentially in coastal New Jersey. Because when even though the moisture is coming north, when a low is to the west, typically the moisture comes directly south to north. So there is a chance that if this clipper system comes a little more sharper in, like a little more deeper, instead of rolling through like Chicago, if the low instead comes through maybe like St. Louis, a secondary low might form, and it might have more time to be on the Gulf Stream before it comes northeast, because after it forms, it's going to immediately move north and northeast, and even moving west. That is a bad scenario for Arctic sea ice. A terribly bad scenario. I'm going to show you current temperatures. But then that's a good scenario. As you can see, the cold air is once again going to infiltrate back into the ocean. That's a very good sign. And Antarctic ice. A lot of you haven't heard about the Antarctic ice. About to hit a record high, breaking last year's all-time high for minimum ice extent. I will show you our Antarctic ice record high. Okay. Hold on. Okay, there we go. Computer unfroze. Arctic ice record high level. See? Record high. Global warming. What the hell? Or sorry for the foul language. New record high. Okay. This is last year. We're about to hit a new record high. Record high, record levels. Not lows, but highs. How could this be happening? We're dealing with climate change in terms of global warming, yet we're dealing with record high ice? Okay, that's unbelievable. That is, and now Antarctic ice is about to hit a record low high. What does that mean? That means the minimum ice extent is going to be the most sea ice ever observed in the minimum, potentially this year. 2011 almost hit a record low, but for 2 years in a row of having record high, that is very good for multi-year ice extent. I think what's going on is, okay, you heard about the ozone layer getting better and better. We're sealing it up. I don't know if it has something to do with that, but when the ozone layer gets sealed up, the sun traps more ozone, or the sun more UV rays get trapped, so that heats up the stratosphere. But with the stratosphere heating up, that cools down the surface. We observed this earlier this winter, or just now recently, that caused a cold outbreak, sudden stratospheric warming. But that is not caused by ozone, that is caused by weather pattern. But ozone can lead to global cooling, but not because of reduction in visible light, but because of reduction in ultraviolet rays. By heating up the ozone, you also cool down the atmosphere. So, atmosphere works in layers. And the mesosphere is actually the warmest in the winter, not in the summer. The mesosphere is coolest in the summer. So, maybe by holding up the ozone, potentially we're actually making the climate cooler, not warmer. So maybe it is possible that some of the warming we observed on this planet has been due to the lack of ozone. And by stopping ozone pollution from chlorofluorocarbons, we are saving the ozone layer and indirectly our planet. But CO2 emissions are another threat to our planet, as that it leads to another warming. What is the biggest threat to climate change other than CO2? The most potent greenhouse gas is methane. And where does methane come from? It comes from our poop. It comes from cow manure. It comes from decomposed stuff in decomposed bogs and tundra. And when global warming melts that, it's going to release it all back into the atmosphere. So we should prevent that by tapping it. Sorry.